Okay, everybody. Today we're going to talk about on this lesson. We're going to talk about something called percent yield. And again, when we talk about yield in general, we talk about how much of something you can make. So if we take a look at, and we can add this to our study on chemical reactions, if we take a look at what yield means, okay, yield is basically the amount you make or receive from a reaction, all right, or something. So if you think of cookies or you think of baking, and you look at a recipe, the recipe yields 24 cookies. But this is in theory, right? In theory, if you cook everything correctly, you should make 24 cookies. Now, again, what you actually get from this could be different from what theoretically you could get. So, again, a yield simply means how much you produce. So, if something yields something, it produces something. And again, you'll see that a lot in baking. All right, and there's two types of yields, right? There's a yield that you should get, okay, and there's a yield that you actually get when you actually do something. So we need to look at these two a little bit closer. All right, so the first type of yield is something called the theoretical yield. And in theoretical, this is the amount that you calculate from an equation. And again, whenever you do a mental calculation or you think about calculating something or predicting something, you always predict it in theory, right? You predict it before you do it. Okay, so your theoretical yield is always what you get when you calculate something using one of these chemical reactions. Okay, the actual yield is if you actually did it in an experiment, or you went to the chemical bench, or you went to the chemical lab and you actually did this. And what you actually get from the experiment, usually, most of the time, almost always, can be different from what you calculate. Okay, so that would be the actual yield. All right, now again, the one that's in the experiment, this particular value must be given to you in the problem. All right, because there's no way you'd be able to get this unless you actually did it in the lab. All right, so what we take a look at it, we take the ratio between the two. If we take the actual yield of what you actually get, we divide it by the theoretical yield, and we times that by 100, we get something called a percent yield. Okay, and you can think if this is how efficient that you are. So, for example, if really quickly, if you are supposed to get 24 cookies, but you actually make 23, okay, then what would be your efficiency? Okay, so or your actual or your percent yield would be 23. You made 23 out of the 24 cookies, okay, and you'd be like times 100. This would be 96% yield, or efficiency would be 96%. And again, of course, with cookies, it's not a big deal. But again, if you were running a bakery and you were making cookies and you want to make sure that you were exactly converting all of your reactants to products, you'd probably want to try to make this as close to 100 as possible. Okay, so that's just really what we get here. So this is no different than what we've been doing with our equations in the last lesson, in lesson 7. But we're just adding a little bit to it. We're adding this experimental value to it. All right, so for example, it could be asked very simply like this. We say Joey calculates from an equation that he should produce, again, should produce 35.6 grams of chemical X. Okay, so that should produce is my theo, right, from an equation. Upon finishing the experiment, he obtains 31.7 grams. Again, this would be my actual because it's from the experiment. All right, so I simply would take my actual, okay, over my theo times 100. Okay, and it's always helpful to write the equation. So I would take my actual, which is my 31.7, over 35.6 times 100. Okay, and I would end up with about 89%. Now, again, is this good? Is this bad? Again, that's always going to depend on the reaction. Some reactions are very efficient, some aren't. Sometimes we can manipulate things about the equation. We talked about collision theory. We talked about different ways you can speed up reactions and then make the collisions, more effective. That could affect this type of yield depending on the reaction. All right. If we put this together into one big equation, we can use the equations that we did from the last lesson, and we can add this little piece to it. So if we take a look at this equation, we can see, okay, in a lab, when in a lab, when 84.8 grams of iron oxide reacts with excess carbon monoxide, again, excess reactant, okay, 54.3 grams of iron is produced. Okay, so this, because it's in a lab, okay, this is going to be my actual. Okay, sometimes it's not easy to tell, but in this case it says in a lab, that's my actual. So I'm going to label it my actual, but we're looking for the percent yield of iron. So we're looking for the actual over the theo. However, in the problem, it's not given the theo. So what I'm going to do is I'm going to find the theoretical yield. So I need to find, okay, how many grams of iron is produced. So I want to find how many grams of iron, okay, that I theoretically would produce, okay? And how am I going to do that? I'm going to start with my mole problem. So I'm going to use my 84.8 grams of iron oxide, which is my Fe2O3. Okay, and of course I got to get into the mole. So I'm going to quickly divide that by my gram formula mass, which is 160. Again, take your time to do that. Again, iron is 2 times 56, and oxygen is 3 times 16, which is 48. So the 48 and the 112 is 160. All right, so just see where I'm getting that. Okay, and that's going to equal 0.53 moles of Fe2O3. Okay, and now I'm in the mole hole. My coefficient is 1 here, so I'll put that over 1. Okay, and I'm looking for my iron, right? So 54 is produced. What's my percent yield of iron? So I'm looking for my iron, so it's going to be my X moles of iron over 2. Again, keep going back and checking what you're looking for. Fe over 2. That's my mole hole. Okay, I simply cross multiply. So I can do 2x equals 0.53, and I get my 1.06 moles of iron, right? Because that's what I'm looking for. So again, looking for percent years of iron. Okay, and now what do I want to do? I want to change to grams, so I want to multiply by the GFM. And again, the GFM is 56, so I can multiply by the 56 grams per 1 mole. Mole cancels with mole. We're looking good. Okay, and we end up with 59.4 grams of Fe. Now, what does that really mean? That simply means that if I do this in a perfect world, when I take Fe2O3 and I take 84.8 grams of it and I react it with enough carbon monoxide, I am going to produce exactly, in a perfect world, I would produce 59.4 grams of Fe. However, in this lab that this person did, they actually got 54.3, which is not bad. That's pretty close, right? 50.3 grams. So the question asks you what's the percent yield. So my percent yield, all right, is going to be my actual over the theo. All right, so my actual was 54.3, which is what you actually produced, over what my calculation told me I should produce, which is 59.4 grams. Notice that the actual is smaller than my theoretical. That's the way it's usually going to be. In fact, most of the time, that's the way it is. Okay, and I times that by 100, and I get 91.4 grams. Sorry, no, not grams. 94.1% iron. Now, is that good? Is that bad? I don't know. It depends on the reaction. It depends on what you're looking for. Again, if I was making iron out of this, and again, this is one of the ways that I guess steel is made, is they making iron, you would want to maximize and check your collision theory and check your reaction and how you're actually mixing these and what you're doing with your reactants in order to maximize the amount of iron, if that's what you're doing or if that's what you're selling. So in a company, if you're selling things, you would want to maximize your product. Okay? So that's a good way you can do it. You would do number 3 the exact same way. I will give you the answers here for this. Okay? Again, this is your actual here. Okay? My theo yield, when I do this, my theoretical, the answer to this is 33.2 grams of SiC. That's what I'm going to theoretically produce. That would be my answer. Okay, and my percent yield in this case, which is what they're looking for, yield is going to be about 84%. Again, like I need to mention that here, if you're off by a little bit or you round differently, not really worry too much about it. Try to use the significant figures that are in the problem. So again, in each of these 2 problems, there's 3 significant figures. So you probably want to use 3 significant figures. Again, that is a good guideline. All right, so that's how you do it. These are the two answers. You would do this problem very similar, almost the same that you do this one. Watch your numbers. Have a great day.